Substitution is going to be our usual method for solving a system of nonlinear equations, simply because, as we'll see shortly, elimination usually won't work. In linear equations, we could always choose either method, but in nonlinear equations, sometimes we will be forced to use substitution. Fortunately, we very often encounter these systems set up in a way that makes substitution easy, because we very often encounter nonlinear equations in settings where at least one equation represents y as a function of x. In other words, one variable is already expressed in terms of the other. In this system, for example, equation 1 is already solved for y. So to use substitution, we'll take equation 2 and plug 1 into it. So we have x times y is equal to x squared, and that's equal to 8. So in other words, x to the third is equal to 8. We know how to solve that, though. That means that x is the cube root of 8. We don't need a plus or minus because this is an odd root. X is 2. To find the value of y that goes with that, we could use either equation. But 1 is going to be easier because it's solved for y. So y is going to be 2 squared, which is 4. And we can check that in 2. X is 2, y is 4. Multiply those together, we really do get 8. This system has one unique solution. X is 2, y is 4. This time we got lucky. We had exactly one solution to our system. In the next example, we're going to not get so lucky, and we'll see how we go about finding the value of the second variable when we got more than one solution in the first place. In this example, one of our equations is linear, equation 2. But that's okay. The system is still nonlinear because one of the equations is not linear. Okay, we're going to solve this system, and we're going to use substitution. Equation 2 is also already solved for y, so we're going to substitute that. We're going to plug equation 2 into equation 1, and we'll have x squared plus y is equal to 5x minus 13 squared equals 65. Okay, let's go ahead and multiply this out. X squared plus 5x all squared, that's 25x squared, minus 2 times 5x times 13, that'll be 130x, plus 13 squared, that's 169. Let's see, combining like terms on the left, we'll have 26x squared minus 130x plus 169 is 65. Subtract 65 from both sides. Fortunately, we notice that 26 is a common factor on both sides. So factoring that out, we've got 26 times x squared minus 5x plus 4, which we can factor further as 26 times x minus 4 times x minus 1. our values of x. We can have x equals 1 or x equals 4. So we got two values of x. We must plug in both of these values to get the corresponding values of y. Each x has a different corresponding value of y. And I'm going to use the linear equation for this, because nothing weird happens when I solve the linear equation. So when I plug x equals 1 into equation 2, I get y is 5 times 1 minus 13 is negative 8. When I plug x equals 4 into equation 2, I get y equals 5 times 4 minus 13 equals 7. The system has two solutions. The pair x equals 1, y equals negative 8, and the pair x equals 4, y equals 7. Those two are the solutions to this system. I can't rearrange those. I don't have 1, 7, for example, as a solution, because x equals 1 did not give me the solution y equals 7. And we can absolutely plug these into equation 1 to check. I'm not going to make you watch me do that this time. It does work out correctly. Those two pairs are the solutions to this system.